Today we're going to be learning about how to add and subtract radicals. So, like radicals are radical expressions that have the same index and radicand. So if you remember, index is the number that goes in the corner and radicand is the number that goes underneath. So an example of this would be the 7th root of 11 and 8 times the 7th root of 11. So think of the 7th root of 11 as like a like term. So we can add and subtract like radicals just like you combine like terms. So we need to add and subtract you need the same index and radicand. Unlike multiplying and dividing where you just need the same index, now we need a little bit more. So what I like to do, if I'm adding and I notice that there's the same index and same radicand, I like to put a box around it. Then I have A boxes and B boxes, so I have A plus B boxes. Just like if I had 5x plus 2x, I'd have 5 plus 2x, or I'd have 7x. Same thing for subtraction. If I see something that has the same index and radicand, I like to put a box around it. So if I have A boxes minus B boxes, I have A minus B boxes. So let's try out a few examples and it should make a little bit more sense. In this first example, if I'm asked to add the square root of 2 plus 3, the square root of 3, notice this 2 and this 3, they're different radicands, so these are not like radicals. I cannot combine them. However, in the second example, notice I have the square root of 5xy and the square root of 5xy. Those are the same term. If there's nothing written in front, I have one of them. So I have 1 boxes and I have 8 boxes. So in total, I have 9 boxes, or 9 square root of 5xy. So it's really helpful to make that box around like radicals. So let's try to simplify a few of these. In this example, I have 3 square root of 5x minus 2 square root of 5x. So if I have 3 boxes minus 2 boxes, I only have 1 box. Or 1 the square root of 5x, which is just the square root of 5x. In this next example, I have 6x squared square root of 7 plus 4x square root of 5. There's different radicands here, and they're already simplified. So there's nothing else I can do. This is already simplified. Let's take a look at the next example. Here, notice I have the same index and the same radicand, so I'm going to draw a box around them. I have 12 of them, and I'm subtracting away 8 of them, which means I only have 4 left. So 4, the cube root of 7xy. You're going to be really tempted to try to subtract the numbers inside the radical, but don't. They just stay the same. And last up, we have, notice I have a square root of xy here and a square root of xy here, so I can combine them. They're like radicals. If I have 3x plus 4x, that's 7x. So 7x times the square root of xy. Now, sometimes you have to simplify before you realize you can add or subtract. So remember, you can only add and subtract if your radicands and your indexes are the same. So if we're asked to simplify something like the square root of 12 plus the square root of 75 minus the square root of 3, you might think it's already simplified. They can't be combined anymore. But let's try to simplify. So this time I'll use my factor trees to simplify. So 12 is 3 times 4, and 3 is prime, so I'll circle it. 4 is 2 times 2. And then for 75, let's see, 75 is 3 times 25. And 25 is 5 times 5. So now let's try to simplify this and see what we get. So we have the square root of 2 times 2 times 3 plus the square root of 3 times 5 times 5 minus the square root of 3. Now, since I have an index of 2, I'm looking for pairs that can leave the house together as 1. So these square root of 2 leave as 1. The square root of 5 times 5 leave as 1 minus the square root of 3. Now, if you look, I've got a square root of 3, a square root of 3, and a square root of 3. So I have 2 plus 5 minus, since there's nothing written, 1. So 2 plus 5 minus 1 will give me 6. So this answer is 6 square root of 3. Let's try another example. So in this example, I have cube roots. So now I could do this by looking for perfect cubes, or I could do this by looking for a factor tree that has pairs of 3. So this time let's try the other way. Let's try to look for some perfect cubes. So I know 125 is a perfect cube because it's 5 cubed. So 125 goes into 250. I know 27 is a perfect cube that goes into 54. And I know 8 is also a perfect cube that goes into 16. So it might be helpful to just write out these perfect cubes until you get used to them. Then you start to recognize them. Now the cube root of 125 is 5. The cube root of 27 is 3. And the cube root of 8 is 2. Now if you notice, we have some like radicals. We've got 5 plus 3 minus 2, which will give us 6 cube root of 2. The last thing we have to learn about is how to multiply binomial radical expressions. So it seems like a lot, but basically a binomial radical expression is something that looks like maybe square root of a plus square root of b, or maybe a plus square root of b. So it has 2 terms, which is where the bi comes from, 2 terms, and then some kind of radical in it. If we have a binomial radical expression, we're trying to multiply 2 of them, what we're going to do is use FOIL and then simplify. So let's see what happens. Here we are asked, what's the product of this expression? So we are going to multiply using FOIL. So first is 3 times 5, which is 15. Now 3 times the square root of 7, you're tempted to say it's square root of 21. It's not. The 3 stays on the outside and the square root of 7 stays on the inside. Next up, negative square root of 7 times 5. Again, the 5 stays on the outside and the square root stays on the inside. They don't really interact with each other. And last up, we have negative square root of 7 times square root of 7. If we remember our trick, that turns into 7. So we have 15 plus, now look at this, we have 2 like radicals here. So 3 square root of 7 minus 5 square root of 7 is going to be minus 2 square root of 7. And then negative square root of 7 times square root of 7 is just minus 7. So now we'll simplify what we can. The 15 minus 7 gives us 8. So we have 8 minus 2 square root of 7. In this next example, again, we have 2 binomials. So basically 2 addition problems that we're going to multiply out. So first, 4 times 5 is 20. Now, 4 times 4 square root of 2, we multiply the numbers on the outside, so the 4 and the 4 is 16, and the radical stays on the inside. Next up, we multiply these 2 numbers, the 2 and the 5 is a 10, and we leave the square root of 2 on the inside. And again, last, we multiply the 2 numbers on the outside, so 8, and now we have square root of 2 times square root of 2. So we end up with 20 plus, look here, we have 2 like radicals. So 16 plus 10 is 26. And then we have 8 square root of 2 times square root of 2. 2 square root of 2 times square root of 2 is just 2, so 8 times 2 is 16. And last, we're going to combine our like terms, so the 20 plus 16 is 36, plus 26 square root of 2. Next up, we're going to multiply these radical conjugates and see what happens. So remember, conjugates are just, there's the same number, except one has a minus in between and one has a plus in between. So let's see what happens when we multiply this out. We do first, so you get 25. Outer, which is 5 square root of 7. Inner, which is negative 5 square root of 7. And last, negative square root of 7 times square root of 7 gives us a 7. Now, look at what we have. We have 5 square root of 7, and we're subtracting 5 square root of 7. So those cancel out. And we are left with 25 minus 7, which is 18. So when we multiplied by the conjugate, it got rid of the radicals. We're going to use this trick to help us. So sometimes a denominator has an addition or subtraction problem involving radicals. If the radicals are square roots, so only for the index of 2, you can rationalize by multiplying the numerator and denominator by the conjugate of the denominator. So if we have an addition or subtraction problem, take a look at this one. We have a subtraction problem in our denominator. So to rationalize, I'm not just going to multiply by square root of 5 or square root of 2. I'm going to multiply by the conjugate. So in this case, the conjugate is just, instead of a minus sign in between, there's a plus sign in between. So square root of 5 plus square root of 2. And I have to remember to multiply both the numerator and denominator by it so that I'm not actually changing it. I'm just multiplying by a created form of 1. Now, I like to put parentheses whenever I do these problems. I put parentheses around all of these. And now I'm going to distribute and simplify. So 3 square root of 2 times square root of 5. Remember, the numbers stay on the outside and the insides can multiply. 3 square root of 2 times square root of 2. 3 times square root of 2 is just 3 times 2. In the bottom, we have to FOIL it out. So square root of 5 times square root of 5 is 5. Now, square root of 5 times square root of 2 is plus square root of 10. Negative 2 square root of 5 times square root of 5 is negative square root of 10. And negative square root of 2 times square root of 2 is negative 2. If we did this right, all of the radicals in the denominator should cancel. So let's see. So we have 3 square root of 10 plus 6 all over. Now look, these square root of 10s cancel with each other, which is exactly what we wanted to happen. So we're left with 5 minus 2, which is 3. Now the last step, I see if I can divide everything by 3. So these numbers are all divisible by 3, so they can be simplified. I don't have to simplify in the square root. Actually, I can't. So this ends up 3 divided by 3 is 1, so square root of 10 plus 2 is our final answer. Let's try the next one. So in this last one, we have a subtraction problem in the denominator, so we're going to multiply by the conjugate. So we change the subtraction to an addition, and that's how we multiply by the conjugate. So now I'm going to multiply everything out. So 4x times 3 is 12x. 4x times square root of 6 is 4x square root of 6. And then the denominator, 3 times 3 is 9. 3 times square root of 6 is positive 3 square root of 6. Negative square root of 6 times 3 is negative 3 square root of 6. And lastly, negative square root of 6 times square root of 6 is negative 6. Again, look how these canceled, so that's exactly what we wanted to happen. So we're left with 12x plus 4x square root of 6. In the bottom, the denominator. 9 minus 6 is 3. So there's our final answer. And it can't be simplified because 12 and 4 both aren't divisible by 3.